Today, let's talk a little bit about the difference between a space and a thermal zone. And there's an important distinction here between OpenStudio and EnergyPlus. So OpenStudio has something called spaces. And if you recall, you can define space types using the Space Types tab, and you can define spaces using the Space tab. And that's how we normally get geometry into OpenStudio, is by creating spaces. And then we assign those spaces to a thermal zone. OpenStudio has spaces, but EnergyPlus, the mathematical simulation program, does not have spaces. EnergyPlus only has thermal zones. And OpenStudio uses these spaces and space types to blend together. OpenStudio basically blends together these space types to create thermal zones. Now, if you only have one space inside a thermal zone, there's no blending. So let's just take a look at our model, and we will render by thermal zone. Let's take a look at this corner section here with the big windows. And we've got multiple different space types in this one blue thermal zone here. And we can render by space type here. And here we can see that there's a conference space, a lobby, storage, restrooms, corridor. So there's multiple different space types in this one thermal zone. So how do those get treated when they get transferred or translated to EnergyPlus? So OpenStudio takes this energy model and it translates it to an EnergyPlus energy model, and then EnergyPlus runs the simulation. But how does this space look when EnergyPlus gets it? And that's an important thing to note. So what we can do is we can take a look at the input file, the EnergyPlus input file for this. And we'll go to import the IDF. Oops. We'll go up here to click import EnergyPlus IDF file, and we don't need to save this. And we can go to the EnergyPlus input file for this OpenStudio model, and we would go to the folder. We would go to run. And it's going to be the in IDF file. And we'll click open. Okay, and it says that there's a bunch of objects that couldn't be translated. Normally that has to do with HVAC systems. But the geometry does get changed as it gets translated to EnergyPlus, and then it can't get changed back when it gets translated back to OpenStudio. And this is important. So we'll click OK on here. This is what EnergyPlus is running. This is the model that EnergyPlus is running, and you can see it's all one thermal zone like we had specified. But it has basically removed all of the interior walls for that space, because OpenStudio, when it translates the thermal zones to EnergyPlus, all of these walls get lost, and OpenStudio doesn't put in interior partitions in place of those. So what EnergyPlus is doing is it's treating this entire thing as basically an open room. And that's important because we do have solar heat gain coming through these windows that affects this space, but it's also affecting the entire area. It's not getting transferred through a wall, a partition wall. So that's one of the things that EnergyPlus does, or OpenStudio does when it translates it to EnergyPlus. And we can see that this is how our model is set up. It's a simple HVAC system, and we have the single thermal zone for this model. And if we take a look at what our drawing looks like, we actually, we have this area where it's supplying air to a hallway. It's partitioned by walls. We've got a little storage area here, an entryway, a restroom, and then the main conference room. And we can take a look at the architectural drawing to see it a little bit better. But really, so what OpenStudio is doing is it's taking these individual loads. It's taking like the lighting load for this entryway. It's totaling it up. It's taking the lighting load for the conference room. It's totaling it up. Taking the lighting load for the storage room, for the restroom, for the hallway, and it's totaling up all of those lighting loads, and it's assigning it to that single thermal zone so that EnergyPlus can run it. And it does the same thing for people loads, and it does the same thing for equipment loads, and all of those values, outside air loads or ventilation loads, all of those all of these get totaled up and passed to EnergyPlus, and EnergyPlus runs this as a single room with the combined characteristics. So this could be, this could affect our simulation somewhat. So what we need to do is we need to better specify how EnergyPlus it simulates this total thermal zone. So what I have done is I've broken these up into a little bit more numerous thermal zones. So I've assigned this hallway to its own thermal zone because it's got its own supply air diffuser here. I've assigned this entryway to its own thermal zone. It's got its own supply diffuser, and it might be important to kind of keep track of the heat flow through this corner of the space. The restroom has its own thermal zone because it's got an exhaust fan. And then there's a conference space and this storage area. And the conference space and the storage area are basically open to each other. So it's not really important to separate this storage area out into its own thermal zone. So we're gonna, this is still defined as a storage space. It's going to calculate storage space, lighting loads, storage space, equipment loads, people loads, but OpenStudio is going to combine it with the conference space. And like I said, we've got this entryway separated. So let's go back to that model, and we will open it up, see what it looks like. And this is what the model looks like in OpenStudio. And we'll go to thermal zones. So you can see that I've got different thermal zones here, and only these two spaces are combined into a single thermal zone. Now, this entryway technically shares air with the conference room. So this wall right here, it has been designated as an air barrier, or sorry, air boundary. It's an air boundary construction. And what that does is it does a simple mixing based on air changes per hour. And likewise for the conference area, I've assigned air boundary for that. So now EnergyPlus knows that these two spaces are connected, and there's a simple mixing of airflow between these two spaces, as if this wall was not actually a wall. It's called an air boundary. So, and then you can see what the model looks like when we assign it to the HVAC system. We've got our main thermal zone, which is the conference space plus that little storage room. We've assigned another thermal zone to the entryway, a thermal zone to the hall, and a thermal zone to the restroom. And then that's what that looks like. And so we can take a look at what the EnergyPlus input file looks like when we have, now that we've changed those a little bit. Okay, so this looks a little bit better. EnergyPlus is now kind of designating these as separate areas, and it's calculating airflows based on these separate uses and different load patterns. And we still have this conference room. We don't have or we now have these interior partition walls that separate the spaces, with the exception of this small partition wall that is associated with this this kind of open storage space in the room, which shouldn't affect our model too much. So if we take a look at the outputs for our models, we can kind of quantify what the energy difference is, the energy use difference is between these two models. And if we look at total electricity consumption, we can take this number here we can do a calculation to find out what the kilowatt hour difference is. And then this is the original model. So it looks like our modified model is actually using about 5,000 more kilowatt hours. This is our original model where EnergyPlus treated it as an entire one big space. And this is our model after we separated those spaces into their constituent parts. And part of this, I believe, has to do with the solar heat gain. So in our original model, the solar heat gain from these windows was getting distributed across the entire thermal zone. which was this entire area. Now, looking at our new model, the solar heat gain is only getting distributed across this smaller area. And this area is actually our control zone for the HVAC loop. And if we go to, we can look at it. We go to the HVAC loop and our controller. So our controller is controlling off of this thermal zone RTU3, which is this one here. So I believe what is happening is the that the solar heat gain from the space is just more dense, and it's driving that it's driving the system more to heat or even potentially cool during the wintertime if there's the heat loss is getting it's only getting distributed across this smaller area. So that does affect how the system works, and you can see that once we put in those partitions, our energy use did go up. So that's something to be aware of when you're modeling with OpenStudio. OpenStudio has made it very easy and convenient to drop in space types for these, and sometimes it's best to just assign a thermal zone for every single space that you have in your model, and that's really easy to do with the user scripts that I cover on a different video, but it's basically this one here, and that will allow you to that will allow EnergyPlus to run a little bit better energy model. Okay, thank you. Please like and subscribe.